Hello student, welcome to the one more video session of microcontroller and embedded system. This is Vasanth Nayak from Canara Engineering College. So in this session we will study the embedded systems application and domain specific. That is the application of the embedded system in a specific domain area. So as we know, embedded systems are application and domain specific, means the embedded system cannot be a general purpose system. So general purpose system can do a general purpose system can perform a general task, whereas embedded system is meant to perform a specific task or a couple of tasks. So because of this they are used in different area like electronics, telecom, automotive, industrial control, etc. It is possible to replace the general purpose computing system with the closely matching with the existing system, but it is not possible to replace any type of embedded system with the other embedded systems, because embedded systems are meant for specific application, specific domain, etc. And the design of embedded system is unique in nature, so we cannot replace the embedded system with other embedded systems. So embedded systems are highly specialized in functioning and are dedicated for specific application. Hence, it is not possible to replace the embedded system developed for specific application in a specific domain with another embedded system designed for some other application in some other domain. So we will see now one of the important application of the embedded system is washing machine. So normally in this particular application, which contains sensors, actuators, control unit and application specific user interfaces like that keyboard, that is application specific oriented, display units that is related to application specific. So here the visible components are divided into three categories. One is actuator part, second one is the sensor part, third one is the control part. In the actuator part of the washing machine consists of motorized agitator, tub, water drawing pump and inlet valve to control the flow of water inside the unit. Sensor part consists of temperature sensor and level sensors. Control part consists of microprocessor and microcontroller based control logic, which is connected to the sensors and actuators. Now, the sensor data is fed back to the control unit. The sensor data is fed back to the control unit and the control unit generates necessary actuator output. So, the control unit also interfaces to the input interfaces like keypad for setting the washing time, selecting the type of material to be washed like light, medium, heavy duty, etc. So this is the schematic or functional block diagram of a washing machine. This is the functional block diagram of a top front load washing machine, and this is a functional block diagram of a top load washing machine. Here you can see the various components like level sensor. One level sensor is here, one level sensor is connected here, and one more temperature is here. Other than that, we have water inlet pipe. This is water inlet pipe, and this is the water outlet pipe with the control valve. You can see here with the control valve to control the flow of water inside the washing machine and outside the washing machine. Then this is the inner tub and outer tub and body case. Other than that, we have user interface like display, small display with the small keypad by which we can select a different type of function like wash, spin, then type of washing, light, medium, heavy. All these things we can make all these functions we can select by means of a small keypad. So how this works? So in the washing machines, like washing machine comes in two models, top loading and front loading. In top loading models, the agitator of the machine twists back and forth and pulls the cloth down to the bottom of the tub. On reaching the bottom of the tub, the cloth work their way back up to the top of the tub, where the agitator grabs them again and repeats the mechanism. But in front loading, in the case of front loading, clothes are tumbled and plunged into the water again and again. So once the wash is over, the water is pumped out from the tub and the inner tub uses the centrifugal force to spin the cloth at several hundred rotations per minute. This is called as spin pace. Other than this, the general principle of working of the washing machines comes under basic controls, mechanism, integrated control panel. Basic control consists of timer mechanism, cycle selector mechanism, water temperature selector, load size selector. Then other mechanism includes of motor, transmission, clutch, pump, agitator, tub, outer tub, water inlet valve. These comes under mechanism. Then integrated control panel consists of microprocessor and microcontroller, which is interface to the input and output interfaces or control algorithm, etc. So input interface in this case includes keyboard, which is application specific, which consists of wash type selector, wash, spin, all those things, cloth selector, light, medium, AV, etc. Output interface include 7-segment display. Other type of interfaces which are invisible to the end user are different kind of sensor interfaces like water temperature sensor, water level sensor, and actuator interface including motor control for agitator, movement of control, inlet water flow control, etc. So second application is in the automotive domain. So the major application domain of the embedded systems are consumer, industrial and automotive. So the diagram shows here how the various types of embedded system blocks are used in automotive. So all these arrow marks shows the various types of embedded system like engine control, instrumentation, air conditioner, which shows the application of the embedded system in automotive area, automotive applications. So inner working of automotive embedded systems. Automotive embedded systems are one where the electronic take control over the mechanical system. So it is widely used from simple mirror and wiper control to complex anti-lock brake system. So automotive embedded systems normally built by using microcontroller or DSP, or sometimes it is called as hybrid, that is also known as electronic control units. So number of embedded controllers vary depending on the different types of vehicles. It will be from 20 to 40 in the ordinary vehicle, and in the luxury vehicle it will be around 100 embedded controllers will be there. So electronic control units are classified into two categories. One is high speed electronic control. Second one is low speed electronic control unit. High speed electronic control are deployed in the cases where fast response is required in areas such as anti-lock braking system, engine control, then steering controls, fuel injection systems, etc. And low speed electronic controls are adopted in wiper control, mirror control, seat control system, headlamp and tail lamp control, sunroof control unit. Other than that, audio control, passenger and driver door locks. In all these areas, low speed electronic control units are used. So the communication buses inside the automotive. The automotive application make use of serial buses for the communication because it's widely reduce the number of wiring required inside the vehicle. There are three types of communication buses are there. One is control area network CAN. Second one is local interconnect network LIN. Third one is media oriented system transport most bus. These are the three type of serial communication bus used in automotive system. Now first let us discuss now the control area network. So CAN was originally proposed by Robert Bosch, the pioneer in automotive embedded solution providers. And the speed of the CAN supports from medium speed, that is 125 kbps to high speed around 1 mbps, and generally employed in safety systems. In safety systems like airbag control, then engine control, anti-lock brake system, etc. Next one is local interconnect network. This is one more serial interface used inside the automotive embedded system. So LIN bus is a single master multiple slave, and it is a low speed single wire communication, and it can communicate up to data rate up to 20 kbps. And LIN bus is employed in application like mirror control, fan control, seat positioning control, window controls, positional controls, where response time is not critical issue. So other than that, we have third type. Third type is nothing but media oriented system transport MOST bus. So MOST is targeted for automotive audio and video equipment interfacing, used primarily in European cars. So MOST bus specific define the physical, electrical and optical parameter layers as well as application layers, network layers, media access control. So MOST bus is an optical fiber cable connected between electrical optical converter and optical electrical converter, which would translate into the optical cable MOST bus. Now, the key players in automotive embedded system, embedded market, the key players of the automotive embedded market can be visualized into three verticals. Then one is the silicon providers, second one is the tool and platform providers. They provide tool and platforms. Third one is the solution providers. Silicon providers are responsible for providing necessary chips which is used in the application of automotive, like applications of control unit which is used in automotive domain. This chip may be standard product like microcontroller or DSP or DAC chips, etc. Or it can be something like application specific integrated chip also. Next, tool provider. The tool and platform providers are manufacturers and suppliers of various kinds of development tools and real-time embedded operating systems which is required for the automotive domain. Like tool falls into two categories. One is embedded software application development tool and embedded hardware development tool. Solution providers are responsible to provide the complete solution for automotive applications, making use of chips, platforms and different development tools. So now we will see the next topic, that is hardware and software code design and programming model. So the traditional approach of design of embedded system is like the partitioning of hardware task and software task at the early stage. Like what and all tasks need to be done by software, need to be done in software area, and what and all tasks need to be covered in hardware area. So here software group take care of the software architecture development implementation, whereas the engineers from the hardware group responsible for building hardware required for the product. So there is a less interaction between hardware between the two teams, and sometimes the work will go in either serially, that is serially like either they complete first hardware task, then they will move into software task, or they will complete first software development, after they will move into hardware development. So the development happens in terms of either serially or parallel. Once the hardware and software are ready, then the integration of both is performed. But because of lack of interaction, this leads to several problems. That's why in embedded system, the one more approach is used, that is called as novel approach for embedded system, where hardware and software are co-developed instead of independently developing the both. Hardware and software are co-developed. So in the novel design approach, so there are fundamental issues like in the hardware and software code design. What are the fundamental issues? The fundamental issues related to selecting the model, selecting the architecture, selecting the language, partitioning the system requirement into hardware and software. These are the different issues needs to be addressed in the code design of hardware and software in embedded systems. So first let us see selecting the model. So model is a formal system consisting of object and composition rules. Models are used for capturing and describing the system characteristics. Before any design goes into actual prototype, the first models are used to capture and describe the particular system characteristics. So most often designers switch between varieties of model from the specification stage to the implementation stage. For example, in the specification stage only the functionality of the system is focused. So once it comes to the implementing aspect, there will several issues arise. That's why the designers, they will switch between varieties of model from the requirement specification to the implementation aspect, from the requirement stage to the implementation aspect. So second one is this is the first one, selecting the model. Second one is selecting the architecture. The model only captures the system characteristics. It does not provide information how the systems can be manufactured. Model gives only characteristics of the system. It does not provide information how the system can be manufactured. So this is done by the architecture. Architecture specifies how the system is going to be implemented. For that, different types of architecture components are necessary. What are those architecture components? The architecture components are controller architecture, then data path architecture, or it is a control algorithm architecture, then complex instruction set computing architecture, reduced instruction set computing architecture, very long instruction word computing architecture, single instruction multiple data SIMD architecture, or multiple instruction multiple data MIMD. This is SIMD architecture. These are the common architectures are used in the system design. So first let us see the controller architecture. The controller architecture implements the finite state machine model using FSM. Like any embedded system, there should be implemented in finite state. It cannot be remain in infinite state. So control architecture implements the finite state machine model by using register and combination circuit, where register holds the present state and combination circuit holds the next state and output. Now data path architecture, nothing but control algorithm architecture. Actually, it is best suited for implementing data flow graph model, where the output is developed or generated based on the set of predefined input. So data path is the channel between input and output. Data path architecture, in the data path architecture, data path may contain registers, counters, files, memories, ports along with high speed arithmetic units. Port connects to the data path and multiple buses, etc. Next we have something called as finite state machine data path architecture, which combines the advantages of both controller architecture and data path architecture. It implements a controller with the data path. Controller generates the control input, whereas the data path processes the data. So data path here contains two input output port, two types of input output port. First type of port is used to connect with the control port. Second type of port interface the data path with the external world for the data input and data output. Now we have the third set of architecture, that is complex instructions set computing architecture, which uses instruction set representing complex operation. We know CISC instruction. What is the main characteristic of the CISC instructions? CISC instructions are complex in nature. Complex in nature means it replaces many multiple simple instructions. So because of this replaces multiple simple instructions, so it requires additional silicon, it requires additional hardware or silicon for implementing the microcode decoder for decoding these instructions. So here emphasis on hardware, but the program written by using CISC instructions are not in lengthy, and it will reduce the memory access or memory requirement or memory size. Now next one is reduced instruction set computing. So reduced instruction set computing makes use of simple instructions. So the length of the program to achieve the particular task will be length of the program to achieve the particular task will be more. Data path of RISC architecture contains largest register file for storing the operands and output. So here emphasis is given on the design of compiler or assembler. RISC instruction set is designed to operate on the register. So next one is very long instruction word. Here the single instruction can perform many operations. This is called as VLIW instruction packages, one standard instruction per functional unit of the data path. Next we have parallel processing architecture. In the parallel processing architecture implements multiple concurrent elements, parallel elements. So those are classified as SIMD and MIMD. SIMD stands for single instruction multiple data. Single instruction, and MIMD stands for multiple instruction multiple data. In the SIMD architecture, single instruction is executed in parallel with the help of a processing element. Single instructions is executed. For example, I am executing operation like some operation, add operation on two arrays. Like the operation is single, but it will be executed on like two arrays simultaneously. Like this is a single instruction executed parallel with the help of processing element. On the other hand, processing elements of MIMD architecture execute different instruction at a given point of time. Then next one is the selecting language. Programming language captures a computational model and maps into the architecture. There is no hard and fast rule to select the language. So there are multiple programming languages like C, C++, Java, and other VHDL language, Verilog, and for hardware requirements, hardware implementation. Certain languages are good for capturing certain computational model. For example, C++ is a good candidate for capturing object-oriented model. On the other hand, a single language can be used for capturing variety of the models. Then partitioning system requirement into hardware and software. This is the last requirement. Like once partitioning, once all these design aspects are taken into the consideration, now it may be possible to implement the system requirement either in hardware and software. So now the designer need to think which of the tasks can be implemented in software, which of the tasks can be implemented in hardware. Some of these tasks can be implemented in software rather than hardware, because if you implement the task in software, later you can change the software based on the requirement. But if you when you implement the task in hardware, then later the changing of the hardware changing of the things in the hardware is difficult. So partitioning system requirement in the hardware and software plays major role here. So in the next session, we'll see the computational models in the embedded design. Thank you for your cooperation.